Hello and welcome to Channels, the Nextflow podcast. You're joining us for episode 43, going out on August the 6th, 2024. And today we've got a really good lineup for you. We've got two Robs from Seqera joining me today. Two of many Robs actually we have at Seqera. Rob Newman and Rob Syme. We're going to talk today all about Data Studios, this really exciting new feature coming out of Seqera. It's really relevant for anyone working with Nextflow. And we're going to tell you why and how it works. Rob Newman, can you tell us who you are and what you do?
I'm the product manager for the platform, specifically with the focus on anything related to data. So that's Data Explorer, Data Studios. I work with the engineering team to build out the functionality of Data Studios. I'm super excited to talk about it today.
Rob Syme.
Hi all, I'm Rob Syme. I'm the scientific support lead here at Seqera. I'm part of the scientific development team. So we're bioinformatician, computational biology, dogs, bodies. We end up doing a bunch of stuff across a bunch of different platforms. Previously to this, I've worked in academia and research environments.
I would say, Rob, you keep us honest when we're building products. You make sure that we're actually delivering what people need.
I'd be using Seqera if I didn't work for Seqera.
There's a chunk of a company you have come from being users to now being developers or everything else. I'm definitely in that same category. Anyone joining a podcast who hasn't heard my voice before, my name is Phil Ewels. I'm also a product manager at Seqera, working with open source. Okay, Rob, you mentioned these words, Data Studios, Data Explorer. What is this stuff?
What we were seeing with our users was that they were running pipelines within our platform, and they had a lot of pain when it actually came to doing their tertiary analysis or troubleshooting workflows. We realized that it would be really great to be able to provide an environment within the platform that allows them to interactively troubleshoot their pipelines or review the data that was output from the pipelines, and also do their own tertiary analysis within the data provided by their pipeline runs. Data Studios was created to simplify that process. It allows you to spin up ephemeral or time-boxed containers with several different environments that we provide out of the box, whether that's Jupyter notebooks or RStudio notebooks or Visual Studio Code. You can mount data within your cloud storage buckets that are attached to the platform through Data Explorer. Explore that data directly within your notebook environments. So if you have a data science team or a machine learning team or analysts, or even just bioinformaticians who want to work through the data that is created by their pipelines, you can do that interactively in the platform using your existing credentials, your existing compute environments. And it just makes the whole process that much more seamless.
It's a use case I'm very familiar with coming from the NF core side. We have these pipelines and we always say, we know that there's a limitation in how far we can push things. We know that this NF core RNA-seq pipeline is not going to run and take you all the way up to your publication grade figures at the end. There's always going to be some final stage of the analysis. We can standardize up to a point, but at the end of the day, every experiment is different. Every study is different. There's always going to be that final deep dive on the specifics, generation of figures and validation of hypotheses. Until now, that's always been a case of you run your pipeline and then you download your data and you go off and do whatever else. It's been a bit of a black hole in the Nextflow ecosystem.
One of the founding principles of Nextflow and Seqera as a whole is this idea of reproducibility, making sure that everything is standardized. With Data Studios, one of the things that we've seen with data scientists is that you can spin up your own bespoke environment with different libraries that are installed, whether it's the version of Python, whether it's the version of whatever library that you use. With Data Studios, that's standardized and it's pinned. So you know that if you're doing analysis within that Data Studio session, you're all using the same libraries. You will all get the same results from the analyses that you do.
Yeah, there's no point in being super rigorous about reproducibility for the first 3/4 of your analysis. And then at the end, it's just a Wild West.
I think one of the other nice things about it is that if you're running in small scale data or if you're doing preliminary experiments, you might think, I could just move my data around. But as your team grows and as the data volumes grow, particularly if you're using blob storage, suddenly moving that data around becomes a real problem. It might take time and it's a bit flaky. The other nice thing that I really love about Data Studios is that you're moving the compute to the data. So like you're operating on the data in situ, where the data lives at rest in S3 or in blob storage.
One of the key pieces of information that we've heard from our customers is that when they want to do tertiary analysis, They're having to go into their cloud provider and spin up an EC2 container. And then they have to manage all the permissions to pull in the data. And then they have to manage that instance. Or maybe it's not even them that are managing it. Maybe they have a system administrator who has to manage it. And that system administrator has to keep track of all the costs associated with it. And it's a huge headache for them. So having this ability to spin up this ephemeral analysis container in the platform is a huge time saver and efficiency saver, and is much more transparent.
We've had this catchphrase about moving a compute to a data for years. And again, it's no point doing that for the 3/4 of the analysis if you then still have to download all the data at the end to do the final bit. It's nice to be able to actually push this the whole way and really follow those principles through to the end of your analysis.
And another nice feature of Data Studio's sessions is that you can do real-time collaboration, whether it's using Jupyter or VSCode. There's a simple one click where you can just say, hey, share this link with a collaborator, provided that user has a role that has permissions to use Data Studios in the platform. They can click that link and they can go and do real-time collaboration in the same notebook environment.
Especially as more and more teams are distributed, the three of us are all sat in different countries, different time zones. The idea that you can just hop in and work together with someone as if they were sat next to you at your desk is really powerful. We've mentioned about mounting data there and making data accessible. Can you tell us a little bit about what Data Explorer is and how this fits into this picture?
Data Explorer allows you to browse and interact with remote data repositories from your organization workspaces in the platform. It supports AWS S3, Azure Blob Storage, and Google Cloud Storage. Based on the credentials that you attach to the workspace, it will automatically create these data links within the Data Explorer tab in your workspace. This allows you to interrogate the contents of the buckets. So you can click down, making sure that all the data structures are there as you need. If you have the correct permissions, you can preview and download the data. The previews that are supported are the Nextflow output files, the command files, the Fusion files. You can also preview text files like CSVs and TSVs. Same with PDF files and also HTML files, and then images as well. If you have the correct permissions, you can actually download that data. This is not only integrated with Data Studios, it's actually incorporated into the pipeline launch and the run details page. If you want to select input data for your Nextflow pipeline, you can open up the Data Explorer modal window and you can drill down into your bucket and choose the data that you want as input data. Once you have fired off your run and it's running, it's producing data, you can then go to the run details page and you can click on the Data Explorer link and it will open up the output directory in the platform in Data Explorer. You can start interrogating and looking at the files that are being created by your pipeline.
I love that feature. The task details and being able to drill down to a specific erroring task is one of my favorite features of the platform. Often in computational biology, you have these huge workflows that are spinning up hundreds, thousands, even tens of thousands of individual tasks. And if one of those tasks goes wrong, 1/10,000th of the pipeline, being able to drill down to that specific erroring and say, what were the input files for this erroring out task? Can I check the logs just for this one little piece of the pipeline in isolation, separated from the rest of the workflow? Because like a lot of computational work, things will go wrong eventually. It's only a matter of time. The work is complicated. So being able to get that sort of precision debugging experience is really nice.
This is something I personally really missed when I switched from HPC to cloud. Before Seqera platform existed, I was running Nextflow on an HPC, and it wasn't too bad because the task hash is there and you could CD into the work directory pretty quickly. But then when I started using cloud instead, it becomes much more onerous to actually get into that directory. I'd often end up having a browser tab there with the file explorer in AWS.
One of the really nice features of Data Explorer is that if you want to get access to public S3 buckets, like the 1,000 Genomes project that has a public S3 bucket, you can mount those public buckets in Data Explorer. You can mount those as read-only. You can explore them and use them as an input to a pipeline, or whether it's helping with the analyses that you're doing in Data Studios post-pipeline run.
Yeah, a lot of public data sets, they say, oh, we made the data public, it's on an S3 bucket. And some of those have an index listing, an HTML page that's generated, which shows you, but not all of them. And sometimes those HTML listings or indices fall out of date. So it's really nice to be able to see exactly what is the data that's in that public directory. What is the data that's been released? Nextflow will do the conversion for you. You can just apply an S3 path and use it as input to a pipeline. But sometimes you need to know what that path is going to be in order to actually get in there. And yes, if you can drop down to the command line, run AWS S3 LS and step through that process, you can do that. It's not super fun. It's lovely to be able to just click through the data.
We talked about a few things here, and visually is maybe more obvious as to how this works. Don't worry if you're listening with audio only, you're not going to miss anything. I'm just looking at the community showcase here on the Seqera platform. We've got Data Explorer along the top. So Rob, you mentioned 1,000 genomes, and I can see that's listed at the top here. So if I click that, there you go. All these files, and then click through different directories. If I look at some pipeline run here, we can dive into specific tasks. So if I drop down and I find FastQC here, and then this is the new tab you were talking about, Data Explorer tab, and I'm straight into the work directory. That's so cool. And I can see all the HTML files, and they load. So it's literally 2-3 clicks from a pipeline run page.
And also, you can see the little link icon. You can copy that to the clipboard, and then you can paste that to a colleague and just say, hey, check out these results. So you don't have to be sending around files themselves. You can just say, hey, just grab this link and go see it.
Also here, I was clicking around randomly in Data Explorer, see iGenomes here. This is on Azure. We've got Azure and AWS here and Google Cloud as well. And all these different cloud providers sat together in one place. And I've got the same interface, and I don't have to think really about how I'm accessing them.
You can see in the top right of the bucket, it says download current directory. Mm-hmm. So you can choose to download everything in that current view, or if you click the code button, this provides you with the cloud provider syntax to be able to download that whole view that you have within Data Explorer. So this is hugely beneficial. Maybe you do want to download a bunch of files and have those on your local host to do some analysis. Provided you have your credentials set up, whether that's AWS, Azure, or GCP, you can very easily just copy and paste this into your terminal prompt, and you can download all the files locally.
Yeah, so I don't want to do this through the browser because it's about 5 terabytes. So it would take a while. It's nice I don't have to go to Stack Overflow and try and remind myself the syntax of how to fetch things off the command line.
It's nice that we give you both the in-browser experience, but also the ability to help drop down.
Downloading within the browser itself is limited. So we do put a cap on that of 1,000 files. But within the command line interface, it's unlimited because you're just doing it locally on your machine. It's not going through the platform.
Yeah, makes a lot of sense. It's basically not using Data Explorer at that point. It's just using the native underlying systems. I think that's a nice thread that I feel like we try and do quite a lot. We build a graphical interface to make stuff easier, but we don't hide the complexity too much. You can still drill down to the fundamentals pretty quickly if you need to. I think that's quite important. So if I hop into the launch pipeline for Sarek, and then sure enough for the input and then the output directory, I've got browse buttons. Super cool. And so now I can jump through all these different buckets I've got set up, select a bucket there in one click, and I don't have to figure out the S3 path. Happy days. Sorry, a bit of a tangent there. I wasn't really intending to talk about Data Explorer quite as much, but it's quite a nice feature. It's one of these things that I feel like I've endured quite a lot of frustration and pain myself personally. So seeing this stuff all slot together is really gratifying. Back to Data Studios. We've got our data links in the Seqera platform. We talked about how we can have all the different cloud providers side by side. I guess that's all managed through centralized credential management within platform. So I don't have to think too much about that. It could even be set up by someone else. I don't have to know what the credentials are. So now what do I need to get Data Studios running?
Typically, all you need is a compute environment that has the right credentials associated with it. You could use an existing compute environment that had the right permissions associated with it, but you can go and create a new compute environment. One of the key pieces is that you need to define the credential associated with the compute environment, because that will dictate what you can and can't mount in terms of data. If you want to read and write within the compute environment creation process in the allowed buckets form field, you have to list the buckets that you want to write back to. That's by design. We don't want people to be able to write data from their analyses to any bucket. We want to be very stringent about that. You don't want to pollute the data in your buckets. So you have to explicitly define which S3 buckets you're going to write your data back to when you create the compute environment. Then when you create your Data Studio session, you can choose to mount data from one or more buckets. And those will show up as read and writable. And they will also show up if they're in the same region as your compute environment, because the data ingress and egress costs aren't necessarily minimal, especially if you're pulling in really big files. So it's transparent to our users about costs that might be incurred.
That's another one of those things which is really nice about working in cloud is if you find a new public data set and it's in the US instead of being in Sweden, I can just create a new compute environment in the US and then launch a data studio there, and suddenly all my data egress fees just go away.
The compute environment is made a little bit easier by the platform with this Forge feature. It's a wizard for creating compute environments. It'll do things like setting up the IAM permissions for you. It'll set up the auto-scaling groups, the AWS Batch queues and compute environments, all those little pieces, which are a bit of a pain, particularly if you're a biologist who doesn't spend a lot of time on cloud. It's lovely to be able to have the platform stand that up on your behalf inside of your account, ready to spin up either AWS Data Studios jobs or Nextflow jobs.
If you don't know what all those acronyms mean, like IAM and stuff, that's the point. You don't need to. Fantastic.
You're living a better life.
Also, one of the nice things about the compute environment is you can specify the instance types. So let's say you're going to build a machine learning model in your Jupyter notebook. You would create a compute environment with GPU-enabled instances. So you have the horsepower that you need.
We've set up our compute environment. We've mounted our data. Those things I do as a one-off, right? I don't need to create a new compute environment every time.
It depends on the number of data studios that you create and have running at the same time. If they're all using the same compute environment, you have to be aware of those restrictions, because you do define the number of CPUs for the compute environment. And if you create 20 data studios all with 10 CPUs, then you'll potentially consume everything that the compute environment can provide. Under the hood, it's all working within the batch, and currently only AWS Batch is supported. So yeah, you got to be cognizant of that. But let's say you've got your compute environment created. So you can create your Data Studios sessions by selecting the Data Studios tab on your workspace. And then there's a really nice simple interface where you can just create or add a Data Studio. Within that, you're defining the container template image that you want to use. Right now, out of the box, we offer Jupyter, RStudio, and VSCode. Jupyter and RStudio, that's a notebook environment when you are doing some tertiary analysis. You can also create a VSCode container, and that is super helpful for troubleshooting pipelines or creating or updating pipelines. So you select your container image template, you give it a name, you can customize that name. We do auto-generate those for you. And then you can give it an optional description as well. So maybe you're doing some very specific analysis and you want to add that metadata. Exactly. Super imaginative. Hello world is great. And then you choose the compute environment. And again, the compute environment is super important because it provides the amount of resources that you can use for this Data Studio session. Then you mount the data. So you click the Mount Data button, and that takes you to this Data Explorer modal, and it shows data at the bucket level.
What I like about this is it's showing a big red exclamation mark to warn me that this is not going to be free because these are in different regions. But even though this is Azure and my Data Studios is going to be running on AWS, that's fine, right? It's still going to mount the Azure data so I can still access it within my AWS environment, which still blows my mind every time I see this.
We can mount the root of the bucket, but sometimes you want to be a little bit more specific. Maybe you have an enormous bucket that is currently hosting projects from lots of people at lots of different times. You can create data links which points to a particular key or prefix. You can think of it as a directory inside of a bucket. And so you're only mounting just a little piece of that bucket that you need for your tertiary analysis. So you can be as discriminatory or specific or as general as you want.
And then you hit the add button. What it's doing under the hood is it's taking that container template image, which is just a Docker file, and it's creating a new container within AWS Batch. It's creating a new job, essentially. Once you start it up, it's continuously running. And you can then go in within the Data Studios interface, hit the connect button, and then it connects you to that running batch job under the hood. And you have your notebook environment or your VS Code IDE. It's mounting data using our Fusion file system. So it's super fast, super responsive. And you can then go in and open up data. So when your Data Studio session is running, it's incurring costs because it's a batch job that is in a running state. What you often want to do is start and stop that analysis container at will. Maybe you're doing some analysis for 3 or 4 hours and then you want to stop. What we've recently rolled out is this idea of session persistence. Every time a running Data Studio session is stopped, a complete snapshot is taken and saved in the working directory of the associated compute environment. It's created as a named checkpoint. And that checkpoint includes all the intermediary work and data not explicitly written back to the cloud storage bucket, and all the notebook configuration. So the environment setup, the settings, the configuration, and any dependencies. And then you can, at any point, you can restart that Data Studio session, or indeed, you can also start a new Data Studio session from that existing snapshot. And no data is lost. The state from the previous session is preserved.
Like Git history, where you finish your analysis session and it creates a new commit. And in the future, you can branch off that, or you can continue working from that state.
So this results in like much lower costs. You only turn on and off your Data Studio session, or start and stop your Data Studio session on demand. It's fault tolerant. It provides improved reproducibility and also portability of your analyses, whether it's just for your individual user or your collaborative teams working. It also means that if you do accidentally leave your Data Studio session running and you go off and get a coffee or grab lunch, or maybe you're done with work for the day, an administrator for the workspace can come in and they can safely stop that Data Studio session. So costs don't needlessly escalate. It's just a one click. And if you compare that to what some of our customers were previously using, having to manage EC2 instances, that's a much more complicated process. So administrators can cleanly stop a running Data Studio session and the environment state won't be impacted. So it's a huge benefit. Also, one of the really nice things about this session persistence is these checkpoints are created every time you stop a running Data Studio, but you can use those checkpoints as the basis for a new Data Studio session. So let's say you want to do some exotic analysis. Maybe there's some library that you want to install, but you don't want to impact the parent Data Studio session. You can go to the checkpoints tab within Data Studios and you can say, hey, I want to start a new Data Studio session from this pre-existing checkpoint, and it will create a new Data Studio session. It's essentially a fork of that environment. And you can choose to keep that environment and keep doing that exotic analysis, or you can choose to roll those changes back into the parent Data Studio session as needed.
Rob, can you show us some of the more typical workflow that people might use this for?
Yeah, sure. I think the thing that comes to mind for most people when they hear about these interactive analysis is taking the outputs from a run and to do this work that we talked about at the beginning of the podcast, generating HTML reports or doing some sort of interactive analysis on those results. So let's look. I have a workspace here. It includes Data Explorer, and I have some data links here. So these links into a bucket, into a particular directory in that bucket. So this is the Data Explorer that we saw before. So I could look at one of these directories and I can see there are some files in here, including a Shiny NGS app. These are different NF core differential abundance outputs. So I can see that data, but let's say I want to interact with the data. I can go to the Data Studios tab. I have a running Data Studio instance here. Before I enter it, I'm just going to show you that I have mounted data in this Data Studio instance. So when I spun this up, I selected these two data links, so these two directories inside of blob storage to be mounted in my instance. And I've given them these names: differential abundance test, full results, and RNA-seq test. And I say I, but it was actually my colleague, John, thank you, who was actually one of the developers of the NF core differential abundance pipeline. And before we jump in, I think it's also interesting to have a look at these checkpoints. These are exactly what Rob Newman was describing before. So I can see that this particular Data Studio has been stopped twice. And every time it's stopped, we have this checkpoint, and I can give it a new name, or if I can also start a new Data Studio based on any one of those checkpoints. So maybe I've installed a bunch of software and I like the software versions that I have here. I'm going to save that and have it as a checkpoint. And maybe I start all my new analysis or all my new projects from that checkpoint. Let's have a look. This is the Data Studio running. It's just a little RStudio notebook, so I can do all the normal RStudio things.
You hit connect there, and then we're still in the browser, right? This looks like RStudio, but we're still running in the web browser. And the URL at the top, that's still Seqera.io.
Exactly. And this URL, I could even save and pass to my colleagues. If they have access to that Seqera platform's workspace, all they need is that URL to connect and see these results and see this analysis. So I can run some code here. And this particular code takes the data that I've launched. So here under root workspace is where you generally live inside of Data Studio, under root workspace. And under workspace/data, you have these two data links that I mounted. So if I mount more data links, they will appear as directories, which look like normal POSIX file systems to my RStudio code, my Python code. It's a really nice thing not to have to think about blob storage. We've all had the luxury of dealing with Nextflow for a long time and not have to really think about the differences between blob storage and local file systems, because Nextflow has this abstraction layer which takes care of all of that for us. And I can just point it to an HTTP file and it'll work. Or I point it to some S3 blob storage and it'll work. But in my custom analysis, often my R scripts will expect local files. I don't want to have to write code that deals with both blob or remote storage like local files. But these emulate a POSIX file system. It's a fused file system under the hood. This is the fusion technology that Rob Newman was talking about. And I can browse these and treat them just like local file systems, even though they're files on remote storage.
And these could be public buckets we talked about before, right? You can mount anything here, no matter how big or who owns it, or as long as there's access permissions.
Exactly. So there's like that complexity that goes away. And the other nice thing is that I can read and write enormous pieces of data to and from those blob storage. A lot of the sort of work that is happening in Seqera is ensuring that computational biologists or bioinformaticians or researchers in general don't have to think about infrastructure. Writing directly to blob storage is a huge boon, because it means that I don't have to think about how much disk before I start my analysis will I need to provision to accommodate all the things I want to do. Often if I'm doing interactive work, we don't necessarily know where it's going to lead. We don't necessarily know how complicated this job is going to get and how much disk we're going to need. So it's very frustrating to spin up an EC2 instance, begin your work, and then realizing that you've only provisioned 200 gigs of data and you really need about 400 gigs. To have to tear that down, maybe attach some new block storage, all of that complexity, it just gets in the way. And it's nice to have that sort of fall away.
And inevitably you end up being super cautious and provisioning way more than you need, which then gets super expensive.
Exactly. So you can treat S3 as this basically infinite disk, which is lovely. So here I just run some R code, and this is a nice little interactive exploration of my differential abundance results. So
this is a shiny app that's running out of the RStudio session, and it's opened up a new browser window here. But even though it's a second browser window, it's still running in the same Data Studios session, running off that background R server that's in the RStudio session.
Yeah, it's complicated deep stack here. So we have Shiny running in an AWS Batch job, running ECS agent, running on a EC2 VM. But I don't have to think about any of that. It's just RStudio with my data.
Magic.
It's really nice not to have to think about that stack. This is a sort of like the classic analysis, but there's something else that I want to show, and that is interactive development work. Often you will do a lot of Nextflow development on your local machine using a small test data set. I strongly recommend you use the NF Core standards of having a test profile, which has a little test data set that you can run in CI/CD or while you're interactively developing. But there are often times where you are doing some debugging and you need a little bit more horsepower, or you're dealing with data that is on blob storage. I have a second Data Studios instance running here that I've called dev environment, and it is running a VSCode instance. So an enemy is running VSCode. I can connect to that. And here I'm dropped down to what looks like just VSCode, but it's running in the browser. I'm running in Seqera platform. And I've got a little Nextflow project. This is some very advanced computational biology work going on here. You'll see this is a workflow with a single process that creates a text file that says hello.
You should use that Data Studio I set up. It had a description, hello world.
Yeah, exactly. It would be very appropriate. But one of the nice things about this is that we are running this Data Studio in an AWS Batch job that has permissions, all the permissions that those AWS Batch jobs run. When you submit Nextflow in Seqera platform, Nextflow runs as an AWS Batch job and then submits all of the component tasks. So I know already ahead of time that this EC2 instance has permissions to submit jobs to AWS Batch. I can see this is running on this compute environment with this name, On-Demand Data Studios. If I look in the compute environments tab, I can inspect the details of this compute environment. and it actually lists the head and the compute queue name. So these are the names that correspond to AWS Batch queues.
So just to reiterate, this is the compute environment that was spun up for the data studios. And when you do that with Tower Forge, as it's called, it creates all the AWS infrastructure for you. And AWS Batch works a little bit like an HPC job scheduler. I guess it's got these different queues. And here, this is the native AWS Batch identifier for that compute queue.
Right. And so this will work if you create the compute environment with Tower Forge, but even if you created it manually, if you're in a larger organization that has very specific policies about how these AWS environments will get set up, and you've created head and compute queues manually, those compute queues will still be listed here in the details page, and I can still submit jobs to them because I know that like these compute environments will need to have the permissions necessary to submit jobs. So I can just copy that. And I've added just a small amount of configuration. I've just dropped this in a nextflow.config in the root directory of the workflow, so I know it's going to get picked up, but I could just as easily pop it in my home directory. So in here, code home.nextflow/config. And maybe I could put it under a profile, maybe AWS or remote or AWS Batch. And then I could switch between running tasks locally and submitting tasks to AWS Batch. This might be particularly handy if you have specific processes that are a bit larger and you would like those submitted to the remote AWS Batch and have the rest run directly on your Data Studios instance.
Okay, so I could run a workflow in a Data Studio, and most of it could run on local executor, which would be the head job running on AWS Batch. But if I have anything particularly big, a single process in the pipeline, which is heavy, I could tell it to use a different queue for that one process, and it would submit those tasks off to a different AWS Batch queue, which has more heavy duty instance types. Is that right?
Spot on. The caveat that you'll need to run Fusion and Wave to provision Fusion and probably inside of Singularity containers for those local tasks. I suspect that most people will probably just want to submit everything to AWS Batch. It's a lot cleaner and a lot simpler, but you have the option of doing that division if you want to get really fancy. And for this podcast, the listeners of this podcast are the sort of people I imagine who probably do want to do the slightly more complicated and fancy things. So it's nice to know that's available. But for most people, these sort of 5 or 6 lines of configuration should be enough.
So we've got a config file, we've got process executor, AWS Batch, and then you're just setting queue, and that's where you've pasted in what you took from the other page.
Exactly. This is the queue name that I've taken from the compute environment details page. The other important detail is I'm setting the work directory to somewhere in blob storage, a particular directory in a bucket that I know this compute environment has access to, and I set the region. I've turned on Fusion and Wave. This enables me to use this S3 blob storage as a work directory.
And that's exactly the same as if you were running a Nextflow manually, right? If you were submitting to AWS manually, it's just very much how it would look.
Yeah, exactly. So you can even do this on a local machine if you want. You can use this sort of environment.
And if you were running locally, you'd have to set up all the credentials and all that kind of stuff. Whereas here, you just magically have those credentials available.
Exactly. It means that one person can worry about all those credential pieces. You might have one person who sets up the compute environment and needs to think about that. And then everyone else, the credentials are just done. You never need to worry about it. So let's just run it actually and see if it does work. We've talked a big game here. So you can see here, I'm in this directory, main.nf, nextflow.config, and I've actually symlinked here the work directory. So the work directory that I've specified here in configuration was actually one of the data links that I mounted when I spun up this Data Studio. So even though I'm using the S3 as a work directory, I can cd into the work directory and see it as if it was a local work directory. So if I want to do some debugging, inspect the command.run.
And I can even see it in your sidebar there in the Explorer. It's just literally as if you were running locally here. You're like hacking the system, exactly. Sort of making AWS Batch part invisible.
So if I run Nextflow run main.nf, it's going to take a second because it's going to submit a job to AWS Batch. But this is a nice, much more interactive way of doing this sort of development when you need a little bit more oomph for your Nextflow pipelines. I would still recommend if you're doing real work that you want to make available to your colleagues and you want to have all the last provenance tracking, that you should submit those jobs via the Seqera platform Launchpad. You can, of course, run with Tower here, but I think this sort of work benefit is only for development. So I can see here that it's run on AWS Batch.
Fantastic. This is very cool. This is something I theoretically knew should be possible with Data Studios, but I don't think I've ever actually seen someone do it. So to see it actually run like this, I love this. Personally, I'm a bit old school. I've been using HPC a lot longer than I've been using cloud. I think the promise of cloud is awesome, but I find it gets in the way quite a lot if I'm actually trying to do anything myself. So this is perfect for me because I can pretend that I'm not using the cloud and I'm developing locally or developing on an HPC. And it all works the same way that I'm used to, but under the hood, I get that infinite storage and I get all that kind of infinite scalability and all the benefits that come with running on the cloud.
Yeah.
And then we've got Git installed in this compute environment. So if I'm happy with how this pipeline is running now, I've done a test pipeline run, I can then kind of git commit, git push, and then launch the same workflow through the Tower UI as I would normally.
Yep, you could even use the TW command line to launch it directly from this Data Studios. So you wouldn't even necessarily need to leave Data Studios to launch the run and have the full provenance tracking and have it available to your colleagues in the runs page here.
Very cool, full circle.
Yeah, exactly.
I feel like there's going to be an avalanche of people trying this after listening to this podcast. And so we're going to see if the number of support requests suddenly jacks up as everyone tries it. So let's start to bring this to a close then. Rob, where are we in terms of what's enabled and what's available to people listening to this today?
It's in public preview, and it's also available for enterprise customers as well. If you're an enterprise customer, it does require a little bit of configuration for your Seqera platform instance, but it is available. It's shipped in the latest release of 24.1. For cloud users, it should be enabled for all users at this point in all workspaces. The plan is for it to go to general availability at the Nextflow Barcelona Summit at the end of October of this year. There are some new features that we're going to be rolling out. It is under heavy development. It's one of our core offerings now. One of the key things that we're going to be providing in the next few upcoming releases are going to be this idea of bringing your own custom environments. We talked about how you have Jupyter, RStudio, and VSCode Docker files under the hood, creating those containers for you in AWS Batch. But for those of you that saw the Boston Summit presentation by Rob Syme and Florian, if you have the ability to define your own custom containers, the sky's the limit. You can have your own Linux machine, a remote desktop even, and you can install any of your own graphical user interface applications, which Rob did do in that demo. So this idea of actually being able to bring your own or define your own custom containers is part of our roadmap and is the next big thing that we're working towards in the next couple of months.
I think out of all the things I've seen on the roadmap, and it's probably the custom containers I'm most excited about. And I think it's a sentiment that will probably be shared by many people listening and many people working in this space. Being able to launch a Jupyter Notebook is super cool, but we're not unique in being able to do that. The idea of being able to launch whatever crazy kind of custom image I wanted in that environment space, that flexibility and that power is pretty unrivaled.
There's a little bit of extra configuration because it is using Fusion under the hood, and the system we've abstracted away. It looks really simple that there's an RStudio notebook or a Jupyter notebook running in the browser, but we have our own web server called Connect that is part of that. If you're going to build custom containers, you do need to both have these Connect components and also the Fusion file system installed as well. There are some pieces that we are going to be developing to make that work, but what it boils down to is we're going to be using Wave, this super powerful piece of software that Seqera has created for doing this container augmentation on the fly. And we're going to be leveraging that extensively in providing this custom environments for data studios.
We've talked about Wave in earlier podcast episodes if people are interested in just how that works. The concept is that I can take any public container image or build any image I want, throw it at Data Studios, and Wave will basically add in all the components it needs en route without me having to do that manually.
The release of the Seqera Containers project that also happened at Boston, you could define your own custom container there. The goal is to make those Data Studios compatible if you want to as well. So you could take that container that was created and is stored in Seqera Containers and just drop that into Data Studios as well. It even gets a security scan. And we're going to be leveraging all of those functionality capabilities within this upcoming release of Data Studios when it goes to general availability.
I love this. It's like we're starting to zoom out and all these different little components we've built or have been isolated until now. They're all starting to link up and you're like, I get it now.
It's all weaving together. It's really satisfying to see.
Rob, your talk at Boston that got mentioned there, it went down pretty fantastically. Not many talks get a standing ovation, and, and it went semi-viral on social media afterwards. There's a YouTube link for anyone who wants to watch it. I'll put it in the show notes. Can you tell us a little bit about what you did? The Boston demo is quite different from what you showed just now, right?
Yeah, fundamentally different sort of workflow. We were demoing its custom containers feature. My colleague Florian had set up a container that would run an Ubuntu install, but also had a bunch of imaging applications. Florian's background is in image analysis, which is an emerging field in computational biology. But a lot of the tools are built to run on a laptop, like a GUI over a Python script. The tools are certainly not developed to run in a web server or in that sort of way. So we needed a way of getting these tools and marrying those up with our cloud storage. This custom container allows us to run those custom Python GUIs on a Data Studio instance to read in data that was produced by a Nextflow pipeline. We had an image analysis pipeline that produced some data, some test data. We took that test data, interactively manipulated it, and generated a model, a segmentation model. Once we've done that interactive work, we took that segmentation model, which was written out to blob storage, and then used as input into the Nextflow pipeline again, and ran our full analysis set. So it was a way of joining together a Nextflow analysis pipeline, married together with some interactive analysis, and then straight back into another Nextflow pipeline, all without leaving the platform.
Really putting proof to that idea of taking a compute to the data. So that's the kind of thing where be uploading and downloading all this data every step of the way, but being able to just go home and stitch it all together, pretty fantastic.
This is something that I think trips everyone up when they're first beginning computational work. Every time you move data around, it's so easy to get lost, and you end up with 4 copies of the data. Which was the data that you used? It's very easy to tie yourself in knots. To have a single source of truth, just have the data at rest and operate on that where it is a real boon. I think it's an underrated time saver, a human cost, both in terms of frustration and hours lost chasing data.
And also monetary cost as well. Data egress is one of these things. It's a hidden cost for cloud computing, but it's where a lot of the charges come from, and it can really trip people up.
Especially with the size of files that we're working with in bioinformatics. They're not just small files. There's multiple very large files.
Yeah. Huge files, it's expensive to move around, but little files are expensive to keep track of in terms of human cost. It works at both ends.
In that demo, if I remember correctly, it almost looked like you were using a desktop environment within the browser.
Yeah, it's just an Ubuntu desktop running window management. So I could spin up a terminal, a little file browser. It just looked like a normal desktop.
I think you showed IGV as well, right? You pulled up an IGV and did some exploratory analysis within that as well.
There's no limit. In these custom images, you can install whatever tools you want. And even if you don't have the tool installed, you could just open up a terminal, run apt-get install, and then pull out the latest tool. So we had an IGV instance running that was loading a huge BAM file that was sitting on the 1,000 genomes bucket, as if it was a local file, interacting with it and viewing an analysis really quickly and instantaneously.
We can talk about creating custom Docker images, and it sounds a bit intimidating, but the idea of just loading up an Ubuntu desktop and running a regular install as if it was your local laptop is very cool.
So if you want to do your own Docker files, absolutely support that. But if you'd prefer just to have a vanilla container and then do your own custom installs interactively, also supported. So you get to choose what sort of mode you prefer to operate at. And I think one of the Seqera, the engineering team and the sort of people on this call, we all come from research backgrounds, and we all know that it's hubris for a provider like us to predetermine what sort of tools and analysis types and how you want to use the products. We know that research is incredibly variable and extraordinarily dynamic. So we can give you lots of options and you can explore. And we're excited to see methods and what tools are used by the community.
You said the custom containers is a big thing. It's coming. Is there anything else on the roadmap? Any teasers you can drop for us?
When we've been doing demos with customers, one of the pain points that they also talk about is this idea of having not runaway compute, but not having a lifespan or lifetime management component part of these analysis containers or these analysis environments. So this idea of defining some sort of session limits. So one of the configuration flags would be, I want to define a finite lifespan for this Data Studio session.
You can say, I don't trust myself. I don't believe I'm going to remember to shut this thing down. So just set a limit just in case.
It's also quite complicated to know the difference between loading in a really big file and maybe you're doing some sort of reformatting of a data table in pandas or doing some sort of filtering. Knowing what's actually computation rather than knowing when the user is idle and they've got up and gone to make a cup of coffee or left for the day on a Friday afternoon. Defining a lifespan where it says once that computation is finished, is this session now idle? And if it approaches that lifespan, to provide a prompt to the user to say, this is now an idle session. Are you still around? Do you still want this running? And if there's no response, to automatically shut that down. This idea of session management, I think, is huge. It's something that many of our customers have said is a real pain point for them right now when they're managing these independent EC2 instances for doing tertiary analysis.
So it's not just a simple countdown, it's actually checking what you're doing. So it's like when you've been watching Netflix too long and it comes up saying, are you still there? Probably time to go to bed.
I think what we're really looking for is our users of the Seqera platform to come in and start bashing on this and really seeing what works really well for them, what is challenging for them still, and then to submit feature requests through our feature request platform at feedback.seqera.io. There's a category for data studios and Data Explorer as well. You can come in and create feature requests. If there are other customers who have already added a feature request for Data Studios, you can upvote that feature request or add your own comment. Then we take all of that input and use it to help define the product roadmap for Data Studios and actually for any part of the platform.
I feel like almost every person I speak to about this, they stay quiet for a little while. You can see the cogs turning. And then it's like, I could use this for... And then the thing they say next is just so variable. Everyone has their own use cases.
We're addressing the top of the iceberg. We're maybe addressing a third of what the use cases are. And then there's 2/3 that are under the water. We don't even know what people are going to do. Part of the fun and the adventure of building this stuff is being able to satisfy customers who have these challenging use cases. They're really not satisfied right now with the processes that they're using to manage tertiary analysis. It's painful for them.
It's really exciting stuff. I'm really psyched to see where this goes and sit in the audience myself as a listener to these talks in Barcelona and see what the next live demo will show. It gets better and better every time. Thanks so much for joining me today, you guys. It's been an absolute pleasure chatting to you and actually seeing some of these workflows and some of these ideas that we've been talking about for such a long time, but actually now materializing. I think it's really exciting. I'm sure that folks listening to this are also going to see the application of these things. So thanks for taking the time out and thanks to everyone who's been listening to the podcast. And we hope that you're as excited as we are.
I would like to add as well, I'm always amazed at what Rob Syme does. It blows me away. We build these things with these use cases in mind, and then Rob and the rest of the SciDev team really push it and show really what matters to people and really show the power of the things that we build. It's just amazing to see.
And we're excited to see the researchers do the same thing at another order of magnitude of complexity.
Are you guys both going to be in Barcelona?
I hope so. Yeah.
Yes, I believe so. Yep.
So I'll see you both there. And also, people listening, if you come to Barcelona Summit, tickets are still on sale right now. You go to summit.nextflow.io. There's an early bird discount running at the moment. Come and see the stuff, chat to us in person, tell us what your use cases are. We'll be keen to hear about it.
Looking forward to those conversations.
Great stuff.
Yeah, absolutely.
All right. Thanks very much, everyone. And until next time.
Thanks, Phil.
Thanks, Phil.